problem 834, sum of distance in tree. There is an undirected connected tree with a node, as we can see from it, and it is labeled from 0 to n-1 and n-1 as is. Yeah, so this is understandable because it is a tree structure. Yeah, but as you can see, inside the edges, this UV just means there is an edge between this 0 and 1, 0 and 2. Yeah, so this is the definition of the edge. We need to return an array answer of length n, where answer I is the sum of distance between the ith node in the tree and all other nodes. Let me just explain the first one. So for example, if this is not 0, so the distance from 0 to 1, 0 to 2, 0 to 3, 0 to 4, and 0 to 5, we just need to sum them up, and it's going to be 8. So the answer to 0 is 8, etc. So for 0, 2, it is 6. Yeah, but we cannot use the brute force to solve the problem because the n is 3 times 10 to the power of 4. It means basically we're going to use the ON time to solve the problem. If we can't use the boundary search, yeah, if we can't use the sorting, then we must use the ON time to solve the problem. Let me make a basic drawing about it. Yeah, so basically we're gonna shift the root. So for example, yeah, by ON time we can get the number 8. So from the node 0 to all other node. So it will take ON time. Yeah, we got the distance from 0 to all other node, it's gonna be 8. But what if we shifted the node from 0 to 2? What's gonna happen? Yeah. So if we shift the node from 0 to 2, as we can see the result, it is 6. But how this 6 is calculated? I mean, here we will not use the brute force to check one by one. We just need to use the shift root method to solve it. Yeah. So from the node 0, it is 8. But if we shift it from 0 to node 2, what's gonna happen? Yeah. As you can see, some of the distance actually decreased. Yeah, some of the distance increased. You see, from 0 to 3, now it becomes 2 to 3. So from 0 to 3, it is 2. Now from 2 to 3, it becomes 1. So 0 to 4, it is 2 before. Now it is 2 to 4, it becomes 1. And 0 to 5, before it is 2, the distance. Now 2 to 5, the distance is 1. Yeah, as you can see from it, it's clear. And also, for 0 to 2, the distance is 1 before. Now, the distance from 2 to 2, it becomes 0. Yeah, so it means some of the distance will be decreased, and this area will be decreased. And some of the distance will be increased. Yeah, so from 0 to 1, the distance is 1. Now from 2 to 1, the distance becomes 2. Yeah. So from 0 to 0, the distance is 0. Now from 2 to 0, the distance becomes 1. Yeah. So as you can see, it decreased by 4 and increased by 2. Yeah. So this means the final result would be 8 minus 4 plus 2. It's gonna be 6. Yeah, as you can see from here, the result is 6. Yeah, but exactly how this is calculated, how this 4 is calculated. Here we call there are 4 numbers, and here there are 2 numbers. Yeah, how it is calculated? How did we know there are 4 numbers? We needed to decrease 4. And how should we know there are 2 nodes? We needed to increase 2. And this is also easier to analyze. We just need to check the size of each of the nodes. So here, for example, for node 0, how many nodes for this tree or for this subtree? There are 6 nodes. And how many nodes for node 2? There are 4 nodes. Yeah, let me just make a drawing of array. So for node 0, here I'm gonna use the index. So what is the size for the node 0 if this is the root? So it's gonna be 6. Yeah, so for 0, 6, and for 1 and for 2 it is 4. There are 4 nodes. Yeah, for 1 it is only 1 node. Yeah, and for 3 it is 1, 4, and 5 it is also 1 node. Yeah, so here it's gonna be 1, 1, 1. Now we can use this size array to get the result. So this is the size. Yeah, we can use this size array to get the result. So because we changed from 0 to 2, yeah, so before it is 8, now we changed it to 2, and how many nodes? If the 2 is the root node for this subtree of 2, so there are 4 nodes. So for this 4 node, it should be decreased, yeah, as you can see from it. And what is the total node? It is 6. Yeah, so it means 8 should plus 6 minus 4. Why? Yeah, because 4 nodes should be decreased, and those 2 nodes, 6 minus 4, should be increased. So this is an increase, and another one is decrease, and the decrease is the 4 node. Yeah, and how it is calculated? We just need to check the size of the node 2, and it is 4. And we just need to calculate this kind of a size array. And the size array is easy to calculate. We just need to use a DFS. Yeah. And for this first one, 8, it's also easy to calculate. We can still use the same DFS to calculate the first index 0 node. The distance is 8. Yeah. After that, we're gonna use another DFS to use the shift root method, shift root DFS. We're gonna just shift all the nodes, and we just need to use this formula to get the result. So yeah, this formula actually, for example, this formula is yeah, let me use yeah, maybe I'm gonna use the result. So result x gonna be 8. Yeah, so the yeah, so I will explain it later. So yeah, basically if I shift from x to y to node, x to y, so the result is my final answer result. So the result y should equal to result x. Yeah, because it is the shift dp. This result x is 8. Result 8 plus n minus, this is 4, this is another 4, 2 times size 2. Yeah, because we shift size y, 2 times size y, this size y. Yeah, so this is the formula. So the result y should equal to result x plus n minus 2 times size y. Yeah. Now let me go to the code editor to finish the coding. I think this explanation is enough to solve this problem. Yeah, now let's just finish the coding part. Let's just prepare the graph first. It's gonna be a default dict, and it should be a default dict. It should be a list. Yeah. Now we just need to check the 2 edges, and we can use gu dot append v, and similarly gv dot append u, because it is a undirected graph. Yeah, we just, because we are just giving edges and it is undirected, and we can just solve it like this. Now we just need to prepare a result array and size array. So the result array would be 0 times n, and for the size array I will give a 1 and first, because for the size I will get a 1 first. I just need to sum up all its children. So for example, this is the root, it is 1. I just need to sum up all the children, and you will see the code immediately to find why I prepared a 1 for it, not 0. Yeah, because this is just easy for the calculation. Now I can start the DFS. So DFS is just from x to its parent, and I need a depth because I need to yeah, I need to get the size array, and this is the size. This size is for size of the node. For example, the node 0, the size is 6. As we can see, there are 6 nodes starting from root 0. Yeah. Now we're gonna check. So for y in gx, if y not equal to parent, we're gonna start the DFS. It's gonna be y and x. And I think you should remember this kind of a template to solving the DFS problem. Yeah, and here gonna be the depth plus 1. And finally, we're gonna update this size array. So the size x should plus equal to all its children size y. So this is why I prepared a 1 before. So for example, for not 0, I just need to use 1 from beginning plus this 1 and plus here. So here, how many nodes? It is 4. So 1 plus 1 plus 4, it is 6. Yeah. But I also need to prepare the result array. I just need to prepare the result 0. Yeah, because I prepared the not 0. So it should be plus equal to the depth. Yeah. So now we need to execute the DFS. So it's gonna be DFS starting from not 0 and parent is -1 because from the root 0 we just need to prepare a dummy parent, and it should not be like these numbers, and normally I choose a -1, or you can just choose infinity or something else. It should also be okay. Here I prepared a -1. It means -1 is not inside the node, and then I'm gonna prepare a depth. It's gonna be 0. Yeah. Finally, I'm gonna return an empty array just to check if everything is okay. Yeah, let's just check the result array and size array just to check if everything is okay up to now. And then I'm gonna continue coding. As you can see, it is okay. So for the first node, it is 8. Yeah, and for others, node 0, the size is 6. Node 1, size is 1, and then node 2, the size is 4. And for all other nodes, the size is 1. It means everything up to now is alright. Now I will continue coding for the next part. Yeah. So the next part will be just the shift. I'm gonna call it a shift root. Yeah, because normally for this root 0, it's gonna be shifted to 1 or shifted to 2. Yeah, and we're gonna update the result. Similarly, it's gonna be the same x and parent, and also it's the same for y in jx. If y not equal to parent, we're gonna execute the DFS. It's gonna be y and x. Yeah, but before executing the DFS, we need to update the result. Yeah, so the result y, as I explained earlier, it should be updated to result x plus. Yeah, so for example, from 0 to 2. Yeah, so this is the result x is the result 0 and should plus something. Yeah, because it shifted to 2, so it should be n minus size 2. Yeah, so it needs n minus size y, and we still need to minus size y. Yeah, so if it is writing like that, I can use size y 2 times size y. Yeah, or size y times 2. Yeah, normally I would like to put numbers at first. Yeah, so it's gonna be minus 2 times size y, and the result y would be updated. And finally, I just need to return the result, but before that I need to call the shift root. Yeah, it should be 0 and -1, and here I made a mistake. It should be the shift root, not DFS. Yeah, let me just copy the shift root. Yeah, this is the entire code. As you can see that this is just the basics, and also this is similar to the shift root. Everything gonna be easy. Let me just run it to check. As you can see, it works. Yeah, now let me submit it to check if it can pass all the testing cases. Yeah, I don't know why it takes so long, but let's just wait for a moment. Maybe it is the networking problem, or maybe my program is wrong. Yeah, let's just wait for a few seconds and check the result. Yeah, basically I passed the testing cases, those 3 cases, but I need to check if I can pass all the testing cases. If it takes too long, maybe I need to refresh. Yeah, because sometimes I have to refresh it to run it again to check if it works. Yeah, I have to reload the page. It is really slow, I think. That is why it didn't work. Yeah, let me just find another page and to check the code again. Yeah, maybe I can find the same problem. Yeah, it is here. It seems I'm not sure. Yeah, so this is my code. It's exactly the same because it is saved. Now let me run it. Yeah, now here it works, but from here, yeah, from here you can see that it's a long time. After that, finally it works. Now let me submit it to recheck. Yeah, as you can see, it works and it's pretty fast. Now let me analyze the time complexity. So the time complexity, as we can see from here, so this is basically ON time. N is the length of the answers. And for here, this is just a DFS, and similarly, this is another DFS. So for the DFS problem, because it is a adjacency list, it is the time of O, E plus V. E is the number of edges, and V is the number of vertices. Yeah. So because the number of the edges is n minus 1, and the number of vertices is n, so the time complexity is O(n). Thank you for watching. See you next time.